Hello student, today I am going to teach you about the Dijkstra algorithm. Dijkstra algorithm is a single source shortest path algorithm. In this Dijkstra algorithm, there is a source from which we have to find out the shortest destination to all the vertices that exist into the graph. Uh, First of all, this algorithm is very much similar to the Prim's algorithm, and this is the algorithm that is based on the greedy approach. It means in this algorithm, we select a source and we try to find out the neighboring node which are at closest distance. Among these nodes, we select the closest one, and from that node, we again we relax the we find out the next closest, and we along with this we keep on relaxing each node, uh, relaxing these node. In this way, at the end, what we get the minimum distance that we have to travel to reach to all the vertices existing in the graph starting from that vertex. Okay, suppose for example you may consider the real world scenario. Suppose you are in Gorakhpur, and there are nearby cities are Lucknow, Kanpur, Allahabad, Banaras, and suppose and you have to find out the minimum distance that you have to travel to reach up to the different cities. Distance, minimum distance to travel to minimum distance you have to travel to reach up to Lucknow, minimum distance to travel to reach Kanpur, and similarly to Allahabad and to Banaras. So this is the very commonly used algorithm, but this is using the greedy approach. First of all, I am going to write the algorithm. Algorithm. Okay. First lines. Source G comma S. This is 5. Uh, this is the simple uh, algorithm of the Dijkstra algorithm. You can understand it very easily. Here what we are doing, we are selecting initializing single source. We are just selecting a vertex as the source in the vertex. Suppose for in the last example that I have told you, that I have selected Gorakhpur as the starting source point from where I want to find out the minimum distance to the different cities. For in the last example, as Gorakhpur was the source, here in a given graph we shall select a vertex as a source S. After that we shall initialize a set S that will remain empty, and empty set S, and after that we shall initialize a set Q. This is Q, sorry, I have written it 5. This is not 5, this is Q. I have initialized the set Q, that is the set of all the vertices that exist in the graph. Suppose in the last example there were 5 cities, so similarly in the graph the number of the vertices will create a set Q, and we shall run following operation until we are there is an the vertex set become empty, until we and while Q does not become 5, or we can say it until the set become empty, we keep on running the following steps. What we do in these steps: first, do U is equals to extract min Q. Here we find out the vertex at the minimum distance from the given set. Suppose we have selected a source S, then we shall retrieve the vertex at the minimum distance, and after that what we shall do, we shall add that vertex to the set U that was initially empty. When we select a vertex, then for each vertex we adjacent to U. Then for when if we have selected a vertex, then what we do, we then for every vertex U that is adjacent to that vertex, every vertex V that's adjacent to U, we run a function relax. In relax function, you can simply understand that, suppose if this node is a start node and a node is at distance 10 from this node. Initially in a graph, only the vertex which has been selected as the start vertex will be at the 0 value, and rest of the nodes will be at value infinity. And by relaxation, what do you do? By relaxation you cool down. Similarly, infinity is considered to be a very high value. We consider that from the start node, all the nodes are at the infinite distance. If we can get any distance smaller than that, then we say that that node has been relaxed. Okay. Similarly, suppose this node was at distance infinity, and now we have found a root that is at distance 10 from this node. Then this node will be relaxed because infinity is greater than 0 plus 10, or 10 is less than infinity. So this node will be relaxed by a value of 10 in place of infinity. So this node will be relaxed by value 10, right? So this is the working of the relax function. Similarly, if a node is at a distance 20, then a node at a distance of 40 will be relaxed to a value of 60. But keep in mind, a node is relaxed only if it is reaching up to a value smaller than its previous value. Okay. If a node is at value smaller the value, and after passing through a node you are getting a higher value, then that will not be called as a relaxation. Relaxation is called when you decrease that node value, right? So now I shall take an example, and with that example it would be much clearer to you. Much clearer to you. Here is the graph. One, 10, 40, 10, 20, 60, 100. Right? So here is the graph, and this graph is having 5 vertices. This graph is having 5 vertices, and sorry. So this graph is having 5 vertices, and the vertices are indexed as 1, 2, 3, 4 and 5. So first of all we have to select the source S, and the source will be at value 0 and the rest of the vertex will be at the value infinity. So as I've told you, it's a single source shortest path algorithm. So first we shall draw a matrix like this. Here the vertices are, we have chosen vertex 1 as the source vertex, 2, 3, 4 and 5 are the other vertices. If it is initially, 1 will be at value 0 because this is the source node, and rest of the vertices would be at value infinity. Here in this adjacency matrix, the vertex 0 that has been chosen as the start vertex will be initialized with value 0, and the rest of the vertex would be at the value of infinity, right? Now what we shall do, we shall find out the what are the adjacent node of 1. The adjacent nodes of 1 are 2 and 5 and 4. The adjacent node to 1 are 2, 4 and 5, and they all are at the distance infinity. So now we shall run the relax function over these vertex. By relaxing through the vertex, as this is the at value 0, so in 2 will reach up to 0 plus 0, it will become at value 0 plus 10. This will be relaxed by a value 10. Node number 4, 0 plus 30. 30 is less than infinity, so it would be relaxed at value 30. Now the node number 5 will be relaxed by a value 100, so it will become at value 100. Here we have via node 1, so this node has been used. This node has been used, and this node has relaxed node number 2, node number 4 and node number 5. Now we shall find out among these which one is the closest one. We shall find out, and we shall add the 1 to the set S. Okay. After that we shall find out which among these is the is the closest one. Among these, the node number 2 is at value 10, that is the smallest one. So we shall select node number 2 as the next node from which we shall relax the graph if it is possible. So through node number 2, through node number 2, this node number 1 we have processed node number 1, right? And after that, among these nodes we shall select node number 2. Through node number 2, there is an edge at which relax node number 3 by a value of, since node number value 2 is at value 10, 10 plus 50 is equals to 60. So node 10, this node is at value 10, okay, and 10 plus 50, 10 plus 50 is equals to 60. So we can relax node number 3 by a value 60. Okay, there is no other edge, so rest of the node will remain at their position, the same value, so they cannot be relaxed any further. So after this, node 2 has been utilized. After that, we shall find out among these values what is the next node that is not in the set, and that what are the nodes that are left in the set Q which can be used for further relaxation. There is a set S, there is a set Q. In set S, now we have two elements 1, 2, and in set Q there are two elements 3, 4, 5. Now we shall select among 3, 4, 5 which one is the smallest one. The next among 3, 4, 5, the smallest one is at 30. So we shall choose fourth node, node number 4, and node number 4 which is at distance 30, okay, as the next node. 30, node number 4. Through 30 there are two edges, the 30 can be relaxed by a value 30 plus 20, 50. So it can relax the updated value 60 by a value 50. So this node will relax node number 3 by a value of 50. Since node number 4 is at value 30 and through node number 4 there is an edge with weight 20 that reaches up to node number 3. So 30 plus 20, it means this can be relaxed further by a value of 50. So we shall relax node number 3 by a value of 50, and there is an edge where, which can relax the node number 5. 30 plus 60 is equals to 90, and node this can relax the node number 5 also. So 30 plus 60 is equals to 90, right? Now thus, now here though we have used node number 4. Okay, so this 4 number node will move shift from set Q to Q set S. Now we shall find out among node number 3 and 5. 3 and 5, which one is the smaller? So here the smaller one is node number 3. So we shall select node number 3 at this node value 50, right? And we shall find out through 50 can we relax it any further, anymore. Through node number 3 we can, there is an edge, outgoing edge, which can relax node number 5 by a value 50 plus 10 is equals to 60. Previously it was at value 90. Node number 3, that is at value 50. 50 plus 10, 60. So it can relax this node by a value of 60, right? So here node number 3 will shift from here set Q to set S. Now we are left with the single node. Now we are left with a single node, that is node number 5. But through node number 5 there is no outgoing edge. But through node number 5 there is no outgoing edge. So these are the final values. So these are the final value of the node: 10, 50, the minimum values in the column, 30 and 60. So by drawing the graph we can say that the values are 0, node number 2 at distance 10, node number 3 at value 50, right? Node number 4 at distance 30, and node number 5 at distance, node number 5 minimum distance is 60. So that's why it is called a single source shortest path, because in this graph now we have mentioned the weight, the minimum distance that we have to travel to reach up to these nodes. These nodes are node number 2, node number 3, node number 4, 5 and 1. The node number, if node number 1 is the source node, then the minimum distance that we have to travel to reach up to node 2 is 10. For node number 5 it is 60, for node number 4 it is 30, and for node number 3 it is 50. Okay, that's all about the Dijkstra algorithm. Now we shall discuss the complexity of this algorithm. What will be the complexity of this algorithm? Okay, sorry. Sorry. To understand the complexity of Dijkstra algorithm, there are two steps. First, we are finding out the minimum element, and then after that we are finding out the neighbor that are closest to it. First of all, and after that we are relaxing. there are two operations. First, finding the minimum, finding the closest neighbor, or this operation is called the extract min. Extract min. And the second one is the relaxation process. At each node, when we find out that this node is at the minimum distance, we perform relaxation. So in the relaxation or decrease key operation. Key operation. So there are two operations, extract min and decrease key operation. In extract min, if we use the binary heap, then in binary heap, then it will take log v steps. Log v, it will take log v step because for every vertex there could be maximum at log v length, and we are running extract min for each node at least once, so it will take v log v time. Okay. Now the relaxation. Since for relaxation that depends upon the number of edges, and if you are using the binary heap, it will take log e time, and we are performing it for every edge, so it will take e log e time, right? So the overall time, so total time is equals to v log v plus e log v e, and that's equals to e log v, roughly, because in it number of edges are definitely equals to or more than vertices, so overall complexity is equals to, so Tn is equals to O e log v, and here we are using the data structure is binary heap, and data structure that is we are using here is the binary heap. So in short, I am just giving you a concise revision of that. This is a single source shortest path algorithm. It uses the greedy approach. In it, we start with a vertex that is considered as a source with value 0, and rest of the vertex are initialized with a value infinity. After that, we find out, starting from the source, the node that are adjacent to the source node. We relax the minimum the node at the minimum distance. After that, we find out the node that are adjacent to it and that can be relaxed. And we there are two sets into it, set Q that is set of vertices, and set S that was initially empty. When we have performed relaxation through a vertex, then we move that vertex from set Q to the set S, and when this finally set vertices set become empty, we stop this process. The complexity, we are using the binary heap to find out the extract min or to find out the closest neighbor, that will take v log v time, and relaxation will take e log v. So final total time is equal to v log v plus e log v, but among these reaction the number of edges is definitely equals to or more than vertices in a graph, so it depends upon e log v. So that is the complexity of Dijkstra algorithm. Thank you.